Okay, today in class what we did was we finished off the first set of prerequisite skills by continuing on with our discussion of understanding properties of graphs. The only real topic that we had to still talk about was the situation where we have more than one curve running around in the graph together. And whenever we have more than one curve, we obviously have the possibility of the graphs running into each other, which is what we call an intersection. Discovering an intersection is accomplished by allowing both equations to be equal to each other by the transitive property and solving for whatever variable remains. Okay. Now what we're basically doing here is, since we're applying the transitive property basically says if something A is equal to something B, and then this thing B is then equal to some other thing C. Well, if A equals B and B equals C, then A must be equal to C as well. This is basically what we're trying to get to accomplish in a problem. Now, we can find anything in these equations that we can basically have in common isolated in one equation or another. Typically, that is a variable that we can spot in the problem where we can look at it and say, you know what, I think I can get those y's in each equation isolated really fairly easy. It doesn't have to be the y's. It could have been the x's. It also could be a constant. However, if you do get two constants basically isolated in each of these equations, well, when you apply the transitive property, you're still going to end up with both of your variables still participating in the problem, and that's probably not the goal. Okay, so what I did here is that, okay, find a single value or variable that both equations can be equal to, and it occurred to me that the y's were both easily isolated in each of these equations. Well, the transitive property basically says if y is equal to x squared plus minus 3 and y is also equal to x minus 1, then x squared minus 3 and x minus 1 must actually be the same value. As such, we can set them equal to each other and then proceed to solve for the variable that remains, which is in this case an x. Okay, so we're looking at a quadratic equation here, and pretty much the only way we'll be able to solve this is we're going to isolate the entire problem, set it equal to 0. Okay, and then we have options. You can use the quadratic formula, which is always at your disposal on a quadratic equation, but you can also look for something a little bit more easier, such as the possibility of being able to factor the trinomial. And in this case, this trinomial does factor by the a times c method. We can factor it down into x minus 2 and x plus 1. From there, the zero factor theorem applies. Okay, x minus 2 is being multiplied by x plus 1, and the result is 0. The theorem says either x minus 2 is 0 or x plus 1 is 0, or possibly both. We consider it a worst case scenario, and we set them both equal to 0, and then we solve them individually. On the left side, obviously, x is positive 2, and on the right, x is going to be negative 1. So we have multiple solutions for x. So we discussed what does that mean to the problem. Well, we're finding intersections between two curves. So that means if we got two different values for x, we must have two different intersections. And we're going to need two different values for y. So we're going to take these x values back to the original problem, and we're going to plug them in. Okay, so we discussed which equation should actually be plugged into. Should we take these values one at a time and plug them into the first one, or should we take them one at a time, plug them into the second, or does one of these x's get one equation while the other one gets the other equation? And the answer is it does not matter. Okay, we're just going to take these and we're going to plug them in. So I took the x squared minus y equals 3 equation and plugged the 2 into it and solve for y. Then I took the opposite equation for the negative 1, x equals negative 1, for no particular reason, just to show you that we can use either equation. Okay, but the end game here is that when x is 2, y is 1, that's an ordered pair. When x is negative 1, y is negative 2, that is also an ordered pair. So we have two different intersections living at those two locations. Okay. The assignment for this day is to do page 8, numbers 6, 7, 19, 20, 27 through 30, 44 to 45, 59 to 60. Okay. We had time in class to work on this. It is an assignment that we are trying to turn in at the beginning of Friday's class. Okay, on your papers. I asked that when people do work, as far as one step and another step and another step in the same problem, to stack that work vertically rather than running horizontally on the line. When you arrive at an answer, please box the answer so that it is easy to see. If you find the need to locate other important items inside of a problem, you can circle those, but please do box your answers. And if we have decimal points arising in a problem, the expectation for AP in calculus is that we are going to have three decimals, three values past the decimal, and no more than three. So we will get in the habit of rounding to the thousandths place on our decimal points in our answers.